7.4 Division Properties of Exponents. Let's look at number 1. It is asking you to simplify this expression, so let's take a closer look at it. When you raise an entire fraction to an exponent, you will have to bring that exponent to both the numerator and the denominator and raise each of those to the power. Here we have it being raised to the exponent of 3. So when we raise the numerator to the exponent of 3, we are raising an exponent to a power. The rule says when we raise the exponent to a power, we multiply them. So 1/3 times 3 would just be 1, or just x. Then we'll have at the bottom 6 being raised to the third power. 6 to the third power is 216, so that's going to be the answer. So typing that in, we have x over 216. That is number 1. Number 2 is asking you to complete the equation. In this case, it wants just the exponent here. So let's take a look and see how we find that. When we divide numbers or variables with exponents, the rule says to subtract the exponents. So we subtract 19 over 6 by 2. Doing so gives me 7 over 6 for my exponent. Now my answer just wants the exponent, so my answer will be 7 over 6. Typing that in, and that is the answer for number 2. Number 3 is asking you to rewrite this as a base to a power if possible. The rule says if the bases are the same and you have them being divided, you subtract the exponents. So 7 minus 2 is 5. Your answer will be 7 to the 5th power. So we're going to choose A because it can be simplified, and we'll type in 7 to the 5th power. That is number 3. Number 4 is asking you to simplify the following and write the answer with positive exponents. Notice how both in the numerator and the denominator, the exponents are negative. So what I like to do in this case is simply flip-flop the denominator and the numerator. Because remember, negative exponents means we got to either move it down or up depending on where it's starting. So just flip it upside down and make the exponents negative. Now we can subtract the exponents. So 6 minus 2 is 4, so your answer will be r to the 4. Typing that in, we have r to the 4 power. And that is number 4. Number 5 is asking you to use the quotient rule for exponents to simplify. So let's take a closer look at it. So we have two different variables with exponents at the top and the bottom. So what we're going to need to do is take each letter separately. So we highlight the x's and just deal with them. So we have x to the 7th over x squared. So we subtract the exponents, we'll get x to the 5th power. Now let's take a look at the y's. Notice how these are exactly the same for both the top and the bottom. Exponents are the same, bases are the same. So that means this all just becomes 1, so there are no more y's. So my answer is just going to be x to the 5th power. So I'm going to type in x to the 5th power. That's number 5. Number 6, it is again asking you to simplify the expression. So let's take a look. So what we're going to do is highlight each of the different variables and constants that we see in our expression. So I'm first going to deal with the constants, that's the 20 and 5. I'm going to highlight them and divide them, so I get 20 divided by 5, which is 4. Now since it is a whole number and the larger number is in the numerator, then this is going to end up being on top of a fraction, should we have one. Now I'm going to take a look at the x's. I have x to the 3rd divided by x squared. I subtract the exponents, I'll get just x. Okay, now I'm looking at the y's. Y to the 5th divided by y 3rd, so I subtract the exponents, so I get y squared. So my answer is going to be 4x y squared. Typing in, I'll have 4x y squared. Number 7 is asking you to simplify the expression. So let's take a closer look at that. So we have two different variables with exponents being divided. So what we need to do is highlight the like ones. So starting with the m's, we have m to the 3/4 power being divided by m to the -2. So the rule says we subtract the exponents. So let's do that on the calculator. So I have 3/4. So let's put in 3/4. So 3/4 minusing a -2. I'm minusing a -2 because the rule says we subtract the exponents and the exponent's negative, so we have to minus the negative. So that gives me 11/4. If you had just done 3/4 minus 2, you would have gotten a different fraction, an incorrect one, and this would have been the same as saying the first exponent was 3/4 and the bottom exponent was a +2, where it isn't, it's a -2, so be careful and make sure you write it correctly. So it should be 11/4. So we should have m to the 11/4. Now let's take a look at the ends. Now the trick I like to use on this is always subtract the larger exponent from the smaller one. The larger exponent is 8, and so we do 8 minus 5, and that gives you a +3. And so what we do from there is we look at where the larger exponent is. It's at the bottom, so that n to the 3 goes at the bottom. So that gives me as an answer m to the 11/4 over n to the +3. Putting that in, I'll have m to the 11/4 over n to the +3. And that is number 7. Number 8, it is asking you to simplify the following expression. So let's take a closer look at that. So we have constants, an m, and a t all being raised to exponents. So start with the constants and make our way to the right. So highlighting my constants, I have 3 squared over 3 to the 5th. The rule says we subtract the exponents. So subtract the larger one from the smaller one. So 5 minus 2 is 3. And since the larger one's at the bottom, I'll put 3 to the 3rd at the bottom. Now I go ahead and look at my m's. Again, subtract the larger exponent from the smaller. So 8 minus 5 is 3. And since the larger one's at the bottom, I'll have m to the 3 at the bottom. Now I take a look at the t's. I would have 6 minus a -5, which becomes 6 plus 5, which is t to the 11. Since the larger one is up top, I'll have t to the 11 up top. Okay, so now I simplify the 3 to the 3rd, which is 27, so t to the 11 over 27m to the 3rd is my answer. So typing that in, I have t to the 11th. At the bottom, I have 27m to the 3rd. And that is my answer for number 8. Number 9, it is again asking you to simplify the following expression. So let's take a closer look at this. So we have constants and 3 different variables all being divided. So let's start with the constants. We have 10 divided by 2, which is 5. Now we don't know if we're going to have a fraction yet, but if we do, that 5 is going to be up top of it because it is a whole number, and the larger number was up top when we divided. So looking at the a's, we have a to the -1 power over a to the 5th power. Subtract the larger exponent from the smaller, so do 5 minus a -1, which will give you 5 plus 1, which is 6. The larger exponent is at the bottom, so that means we'll have a to the 6 written underneath that 5. Now let's take a look at the b's. We have b to the 8 over b to the -1 power, so we subtract the exponents. Again, the positive is up top, so we do 8 minus a -1, so that will be 8 plus 1, which will be 9, which since the larger exponent is up top, we'll have b to the 9 up top. Now let's look at the c's. Subtract the larger from the smaller, so we have 5 minus a negative 3, which will be positive 8. And since the larger exponent is at the bottom, we leave it at the bottom, so c to the 8. So my answer is going to be 5b to the 9 all over a to the 6th c to the 9. So let's type that in. So typing in the answer, we have 5b to the 9 all over a to the 6th and c to the 8. That is number 9. Number 10 is just asking you to simplify the following quotient and write it in scientific notation. We can simply divide these into calculators, so let's do that. So we'll have alpha y equals, and enter, 1.4 times 10 to the negative 8 power all over 7 times 10 to the negative 5th power. And that gives us this, which is the same as saying 2 times 10 to the negative 4 power. So let's type that in. So we have 2 times 10 to the negative 4 power. And that's my answer for number 10. 11 is asking you to perform the indicated computation and to write this in scientific notation. So again, we can divide this into calculator. So let's do that. So we have alpha y equals, and enter, and up top we're going to put 1.5 times 10 to the 8th power. At the bottom we're going to have 5 times 10 to the 3rd power, which gives me 30,000. Now it wants me to write that in scientific notation, so let's go back and I'll show you how to do that. So I have a decimal point here. I need to move it until I make this number between 1 and 10, because in scientific notation, the number is between 1 and 10. So I will go back 4 places, we count backwards 4, and I'll go down to 3. So when I go to the left, I have to add to the exponent, so it will be 3 times 10 to the positive 4. Also because it is a larger number, not a smaller one, but when I move to the left, I add to the exponent, so I will have 3 times 10 to the positive 4 as my answer. So let's type that in. So I have 3 times 10 to the positive 4. That's number 11.